Hello, I welcome you all. The problem reads the 8 kg block is moving with an initial speed of 5 meters per second. If the coefficient of kinetic friction between the block and the plane is 0.25, determine the compression in the spring when the block momentarily stops. So this is just a temporal stop, but at this particular time, we are considering that our velocity is equal to 0 momentarily. Okay. So we do have some kinetic friction there. So let's draw the free body diagram. We have the weight. Okay. And then we have the normal force. And we have the friction force. So this is the normal force. And this is the friction force. And this is the weight. Alright, so there's going to be a point when this particular block is in contact with a spring. And let's say this is the amount of compression that the spring will undergo, right? Let's assume this is the amount of compression. Okay, and then let's say this is our point 1, this is our point 2. Alright, let's call this X. We could have called it S if you want to. I'm just trying to avoid this because sometimes it looks like 5. Let's call it S, X. You can call it S, you can call it X, you can call it any letter, no big deal. So when this block is in contact with this particular spring, as it is moving at this particular speed, it is going to experience a force like so. Okay, and the spring will experience a force like so, and this force is the spring force. Okay, this is the spring force. Right, I'm going to be using the work and energy principle. Initial kinetic energy plus the total work from 1 to 2, then this is equal to the final kinetic energy. But we are saying the block momentarily comes to a stop, therefore the kinetic energy, this part, is just going to be equal to 0. Okay, because the block momentarily comes to a stop. Okay, right. So writing this, then we're going to have that's half mb v1 squared minus the work done due to the friction in this direction, displacement in this direction. This is negative work, so minus fk times x, and then in fact times 2 plus x. There's this distance here, then plus the deformation, right? And then we have the spring, the work done by the spring. Again, it is going to be negative. We have fs this direction, and then the displacement in that direction. This is again negative work, so it's minus half k x squared, and then equal to 0. So let's find what Fk is, which is friction. So we'll say summation of forces in the y direction equal to MAY, and we know that our AY is just equal to 0. We don't have motion in that direction. So we have N minus W equal to 0. Therefore, our N is just equal to mg, which is just equal to 8 by 9.81. Therefore, Fk, we know that is just mu k times N, and this is equal to 0.25 times 8 times 9.81. Great. So rewriting this equation, let's write this equation. We have half, our mass is 8, our velocity, initial velocity is 5, minus 0.25 by 8, this is the work done due to friction. Then we have the displacement, 2 plus x, then minus half, the spring stiffness is 200, then we have x squared. Then we are saying this is equal to 0. So if we were to write this quadratic formula, we'll have 100 x squared, okay, and minus 0.25 by 8 by 9.81, okay, this I get a 19.62 x. Then finally I have just 0.5 by 8 by 5 squared, and minus 0.25 by 8 by 9.81 by 2. So we have a plus 60 plus 76 equal to 0. Okay, 0.5 by 8 by 5 squared minus 0.25 by 8 by 9.81 by 2. Okay, right. Okay, and then 0.25 by 8 by 9.81. There we go. So this is what we have. So let's find x. We have two values, but we're interested in the positive value. This is minus b, which is the minus 19.62 plus and minus. Remember the quadratic formula. Right. And there we have b, which is just a minus 19.62 squared minus 4a. Our a is minus 100 and our c is 60.76. Okay. And we are dividing everything by 2a, which is just a 2 by a minus 100. So we are just looking for the positive value. So x is 19.62 squared plus 4 by 100 by 60.76. Square root of that, we have that. Okay. Okay, there we go. Alright, so we are getting a 0.6875 meters. So this is how much, this is the amount of stretch that the spring is going to undergo. Okay. Alright. As the block momentarily stops. Right, I think this is about it, and I hope this particular video was helpful. And if it was, give me a thumbs up. Like my video, continue subscribing and liking my channel. Let me also make mention of this force here, Fs. Fs is just equal to Fs, we know this is the spring force, is just equal to K times is equal to k times x. Okay. Right, so I hope this video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and see you in my next screencast.